Okay, so today's notes are going to be on literal equations and word problems. We are going to do a brief example not related to those, but we'll get to that in a minute. Our objective content-wise is going to be to solve word problems and literal equations involving algebraic expressions or equations, my apologies. We're also going to have a language objective. That will be to use the structures of a word problem to organize the information given and write an equation. So before we jump into all that stuff, I am going to do a brief example on when equations are always, sometimes, or never true. So we usually work, or in this class, we will mostly see equations that are sometimes true. So in this class, like we've been solving, equations that are sometimes true are equations with one or more solutions, but a limited number. So they're not always true. There might be more than one possible solution, but there's not an infinite number of solutions, but there are some that work. So we're going to do a couple quick examples. So is the equation always, sometimes, or never true? And our first one is going to be 11 plus 3x minus 7 equals 6x plus 5 minus 3x. So that's the equation we're starting with. I'm going to do our 2-column notes. So we're going to do the steps on the right side. The first thing I want to do is combine like terms. So if you don't remember what that means, it means simplifying things that can be simplified. So 11 and 7, or negative 7, I can combine. So 11 minus 7 I know is 4. So I have 4 plus 3x on that side equals, and here these both have an x with a 1 in the exponent or no exponent. So 6 minus 3 is going to be 3x. And then I have plus 5. Now, at this point, you might already be able to tell that this can't be true. So 4 plus 3x can't equal 3 plus 5x. That doesn't make sense, but just so it's super clear, we're going to subtract 3x from both sides. And we will see that indeed it is true. 4 does not equal 5, so that does not work. It is going to be never true. So 3, if not actually equal, it is never true. So when we solved everything correctly, this can't be true, so the equation up here will never be true. So there are no solutions, it's never true. Our second example that we will do super quickly, it's going to be 6x plus 5 minus 2x equals 4 plus 4x plus 1. Again, we're going to start with the same step, combine like terms. So here I have 6x and negative 2x, which I can combine to be 4x plus 5. And on this side, have a 4 and a 1 that I can combine. So I have 4x. Again, 4 plus 1 is 5. So 4x plus 5 equals 4x plus 5. You might already be able to tell that is always going to be true. That is an identity. So again, just to make it super clear, we're going to subtract 5 from both sides. So I subtract 5, and I get 4x equals 4x. And we can subtract 4x as well. And we see that indeed 0 equals 0. So we know that this will always have to be true. If it's the same thing on both sides of the equation, then it's an identity. So I'm going to write that out. If it's the same thing on both sides of the equation, it is an identity. Therefore, so if we, those three dots mean therefore, it is always true. So those are our two examples of never and always. So if you see that, that's what it's asking. Now I'm going to turn the page and go on to our objective related content for the day, literal equations and word problems. So we're going to do two quick examples. So we're going to start with literal equations or equation example. So our literal equation example is going to be the equation C equals 5 over 9, open parentheses, F minus 32, relates temperatures in degrees Fahrenheit and degrees in Celsius. What is F in terms of C? So when it says in terms of something else, it means it wants you to solve for this variable with this variable on the other side. So when it says what is something in terms of something else, it means isolate this variable and leave that variable with all the numbers on it. So right now C is isolated. So right now we have C in terms of F, but they want us to have F in terms of C. So we have to move everything away from the F to isolate it. So that's exactly what we're going to do. I'm going to start by rewriting the problem, or the equation, sorry. And we're going to do our two column notes. At this point, if you want, there's two ways you could do this. I'm going to do the one step way, but I'll write out the other possible way you could do it. So I'm going to multiply both sides by 9 over 5, because that is 5 over 9's reciprocal, or its inverse. So I know 9 over 5 times 5 over 9, 5 over 9 times 9 over 5 is equal to 1, because they cancel each other out. So I'm going to multiply it by 9 over 5 times 9 over 5, and I'm left with 9 over 5c is equal to, those cancel each other, because 9 divided by 9 is 1, 5 divided by 5 is 1, so I'm left with just 1 there. The other thing you could do, which some of you are more comfortable with, you could multiply by 9, then divide by 5. Either of those works, whichever you're more comfortable with. Just multiplying by the reciprocal takes fewer steps. Next thing we're going to do is just add 32 to both sides. So plus 32 plus 32, and I get 9 over 5 c plus 32 is equal to f, which now I have f in terms of c. I'm just going to rewrite it using the symmetric property, because I would like to write f first. So I'm going to have f is equal to 9 over 5c plus 32. and that is F in terms of C. Great, so that's our literal equation example. It's just rewriting and from one variable in terms of another, so sort of switching sides or switching which variable is isolated. Now we're just going to do a quick word problem example. So for this one, we have a rectangular flower carpet in the Grand Place in Brussels, Belgium. Has a perimeter of 200 meters. We also know its length is 3 times its width. What are the dimensions of the carpet? All right, so we're going to start again, 2-column notes, and we're going to first identify important information. So I know that the perimeter is important because that's the only initial number that I'm given. So I'm going to write the perimeter is 200 meters. That's a piece of information I know. I also know length and width are usually important with perimeter. So I'm going to identify length, and I'm going to call that L for now, just so it lines up. And then I also know width will be important, and I'll call that W. And the last piece of information they gave me regarding those two things is that the length is 3 times its width. So I know that L is equal to 3 times the width. So that's multiplication. I know L is equal to 3W. Next thing I'm going to do, step 2, is identify the relationship between the variables. I'm also, sorry, backtracking for a second. Important information is also often the variables we're working with. So important information is most of the time variables. So now I'm trying to relate all of these variables together. So one thing I know is perimeter is equal to the sum of all the sides. And since a rectangle has 2 sides that are the length that are the same and 2 sides that are the width that are the same, I know it's equal to 2 times the length plus 2 times the width. So if I simplify that, I know if I substitute my information, I know that 200 for the perimeter is equal to 2 times the length, which is L, or to put it in terms of one variable, I could plug in 3W. So I know it's 2 times the length, or 2 times 3W, plus 2 times the width, which I'm calling W. If you want to do the in-between step here, I'll write it really small off to the side. So it'd be 200 equals 2L plus 2W, and then I substituted 3W for 2L. So then I'm going to, step 4, solve for W. So to do that, I have 200. I'm going to distribute in or multiply. So I have 6W plus 2W. I combine like terms, and I get 8W is equal to 200. I'm going to divide, sorry, 1 second, by 8. So then I get 200 divided by 8 is the same as 100 divided by 4. So that would be 25 is equal to W. So then second to last thing, I'm going to solve for my length. So since I know L is equal to 3W, I'm going to plug in 25 for W, and I get L is equal to 75. I know W is equal to 25, so last thing I'm going to do is write out the solution. An important thing, always include units. So I'm going to say my width is equal to 25. I know my perimeter was given in meters, so 25 meters, and my length is 75 meters. And that is my solution. All right, make sure you write down any questions, comments, or concerns you have on today's notes so we can go over them together in class.